Binomial expansion. A binomial is a polynomial with two terms. 5y cubed minus 3 is a binomial. It has two terms. The first term, 5y cubed, and the second term is minus 3. Now let's have a look what happens when we multiply a binomial by itself many times. A plus b is a binomial with the first term a and the second term b. A plus b to the power of 0 is equal to 1. Go back to the exponent rule. Anything to the power of 0 is always 1. A plus b to the power of 1 is equal to a plus b. A plus b to the power of 2 is equal to a plus b times a plus b, which is equal to a squared plus 2ab plus b squared. A plus b cubed is equal to a squared plus 2ab plus b squared, which is a plus b squared, times a plus b, which is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. A plus b to the power of 4 is equal to a to the power of 4 plus 4 lots of a cubed b plus 6 lots of a squared b squared plus 4 lots of a b cubed plus b to the power of 4. Now let's look at the pattern in the expansion. This is the expansion for a plus b cubed. We notice that the powers of a start at a cubed, then go to a squared, then go to a to the power of 1, and then go to a to the power of 0. We don't write a to the power of 0 because we know it is 1. The powers of a are in descending order, starting at 3 and finishing at 0. Now let's look at the powers of b. They start at b to the power of 0. Again, we don't show that because anything to the power of 0 is 1. Then goes to b to the power of 1, then b squared, then b cubed. The powers of b are in ascending order, starting at 0 and finishing at 3. If we now look at the coefficients in the expansion, it goes 1, 3, 3, 1. And if you remember back to the work we did on Pascal's triangle, that is one of the rows on Pascal's triangle. Quickly draw the first few lines of Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. I can clearly see that the fourth row of Pascal's triangle is 1, 3, 3, 1, which matches exactly the coefficients of our expansion. And that row of Pascal's triangle can also be written as 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. Remember, it is the third row of Pascal's triangle because the first one refers to row 0. A plus b expanded to the power of 0. We can now start to generalize for any expansion of a plus b to the power of n, which equals, we are going to sum a series of terms from n is 0 to n. The coefficient is n choose r. Term in A is descending, it is n minus r. And the term in B is ascending, it is to the power of r. So the general expansion for a plus b to the power of n is equal to the sum of n choose r of a to the power of n minus r times b to the power of r from n equals 0 to n. Question 1. Expand 2x plus 3 to the power of 4. Our starting point is always the formula. The sum of n choose r of a to the power of n minus r times b to the power of r from n equals 0 to n. In this case, a is equal to 2x, b is equal to 3, n is equal to 4. Question 2. Find the coefficient of x cubed in the expansion 2x plus 4 to the power of 8. Whenever you're asked to expand a binomial, always start with the formula. The sum of n choose r, a to the power of n minus r, b to the power of r from n equals 0 to n. In the formula, I'd like to point out a little pattern. N choose R and b to the power of r. That can be very useful when trying to find the coefficient of a specific term. I use this pattern to make sure that I always get the right term. So I'm going to change the expansion around. So 2x plus 4 to the power of 8 is exactly the same as 4 plus 2x to the power of 8. For in my expansion, n is equal to 8, a is equal to 4, b is equal to 2x. Therefore, I want the term 8, choose 3, 4 to the power of 8 minus 3, 2x to the power of 3. Therefore, I will get 8 choose 3 is 56 times 4 to the power of 5 times 2 cubed times x cubed. Therefore, you get 4, 5, 8, 7, 5, 2 x cubed. The coefficient of x cubed is 458,752. Question 3. Find the constant term in the expansion 2x minus 3 over x to the power of 8. In this type of question, we want to find the term for x to the power of 0. Start by slightly rearranging the expansion to 2x minus 3 to the x to the power of minus 1, all raised to the power of 8. Therefore, a equals 2x, b equals minus 3x to the power of minus 1, and n equals 8. As with any binomial expansion, our starting point is always the formula. So we've got the sum of from n equals 0 to n choose r, a to the power of n minus r, b to the power of r. In this expansion, we want it to equal a constant x to the power of 0. The thing we've got to do is find r. So we've got 8, choose r. A is 2x, so we've got 2x to the power of 8 minus r. B is minus 3x to the power of minus 1 to the power of r, and that must equal some constant x to the power of 0. I can expand that a little further, so I get 8r, 2 to the power of 8 minus r, x to the power of 8 minus r, times minus 3 to the power of r, times x to the minus 1 to the power of r, and that must equal x to the power of r times a constant. I know that x to the power of, it must be x to the power of 0, so therefore x to the 8 minus r times x to the power of minus r, I've just multiplied it out, must equal x to the 0. We have the same base, so we can solve for r. So 8 minus r equals 0, therefore r equals 4. We can now substitute for r. We know that x is to the power of 0, so we can just use the coefficients part. So we get 8 choose 4 times 2 to the power of 8 minus 4 times minus 3 to the power of 4. Therefore, we get 8 choose 4 is 70 times 2 to the power of 8 minus 4 is 2 to the power of 4, which is 16, times minus 3 to the power of 4, which is 81. Therefore, the constant term is 90,720. Question 4. Find the coefficient of x to the power of 5 in the expansion x minus 4 times 3x plus 1 to the power of 6. In this example, I'm going to expand 3x plus 5 to the power of 6 and then multiply that expansion by x minus 4. So for the first expansion, a is equal to 3x, b is equal to 1, and n is equal to 6. So now let's start expanding. So I get 6, choose r. I'm going to have to find r first. A is 3x, so 3x to the 6 minus r times 1 to the power of r. Then I'm going to multiply that by x minus 4. Right, let's multiply out. So we get 6, choose r, 3x to the power of 6 minus r times 1 to the power of r times x, plus 6, choose r, 3x to the power of 6 minus r times minus 4. I'm going to rub that out and just make that 4 and change the plus to a minus. Makes life easier at the end. I now have two parts and I can treat them separately and solve for r in both cases. So I have x to the power of 6 minus r times x to the power of 1, and that must equal x to the power of 5. Therefore, because the bases are the same, I get 6 minus r plus 1 equals 5. So r is equal to 2. On the right hand side, I've got x to the power of 6 minus r must equal x to the 5. Again, because the bases are the same, 6 minus r equals 5. Therefore, r equals 1. Now you can substitute our two values for r. So we get 6 choose 2 times 3x to the power of 6 minus 2 times 1 to the power of 2 times x minus, let's put all this in one big bracket so we don't make a mistake. We get 6 choose 1, 3x to the 6 minus 1 times 4. If you expand that, you get 15 times 3 to the 4 times x to the 4 times x minus 6 times 3 to the 5 times x to the 5 times 4, which equals 1215x to the 5 minus 5832x to the 5, which equals minus 4617x to the 5. So now answer the question. The coefficient is minus 4,617.